Hello, I'm Ahmad Mirabi. In this video I would like to share a short sample of my teaching with you. Let's start with talking about properties of exponential number, or this is also called rules of power. Okay, so first of all, a squared, or a to the second power, is defined to be a number times itself. So second power means a number multiplied by itself. So this is read as a squared, or a to the second power, or simply a to the 2. So higher powers are read like this. For example, if I write down here a to the 4, this is read a to the 4, which or can be read as a to the 4th power as well. So here is a to the 3rd power, or a cubed, which means a number multiplied by itself 3 times. So a times a times a. Okay, so this is definition of power. Now, if you have two exponential numbers with the same base, we write the same base and add the powers. This is multiplication with the same base. For example, x squared times x cubed equals x to the 2 plus 3, or x to the 5. Why is it the case? Here is why. X squared means x times x, and times x cubed means x times x times x. Therefore, we have x multiplied by itself 5 times, which means x to the 5th power. So that's why when you have same base with different powers multiplied by each other, we can write the same base and add the powers. This is the reason. As an example, x to the 10 times x to the 6 equals x to the 16. Another rule is when you divide two exponential numbers with the same base, you can write the same base and subtract the powers. This is division of exponential number with the same base. So x cubed divided by x squared will be, so in the numerator we have x times x times x, in the denominator we have x times x. So we have simplified here, so only 1x remains, x to the 1, or x. This is why the powers are subtracted from each other. As an example, x to the 10 divided by x to the 8 will be x to the 10 minus 8, which is x to the 2, or x squared. Another rule is every number to the 0 power is 1, but x shouldn't be 0. X can be every real number. X can be negative number, x can be positive number, rational, irrational, whatever, except 0. There is a reason for that. A very simple proof or example is looking at this example, that 2 to the 4th power divided by 2 to the 4th power. Once we can take the same base and subtract the powers, so the result will be 2 to the 0. Another way of doing this division is taking the same power and dividing the bases. So 2 divided by 2 to the 4th power. This rule, we're going to read this rule in the upcoming rules. So when you have the same base and you're dividing two exponential numbers, you can keep the same power and divide the bases. So 2 divided by 2 to the 4th power, which will be 1 to the 4th power, which will be 1. So we understand that 2 to the 0 is the same as 1, or every number to the 0 power equals 1. Another rule says every number to the 1 power is itself. Okay, x to the 1 is x itself. So here is another rule. That's when you have two numbers to two exponential numbers with the same power multiplied by each other, you can keep the same power and multiply the bases. So this is multiplication of power numbers with the same power. So we keep the power and we multiply the bases. For example, x squared times y squared equals x times y times y. So we can rearrange the elements of multiplication because of substitution rule, and so in the multiplication we can change the order of multiplication elements in every way we want. So we can say x times y times x times y, and then rewrite it as x times y squared. So looking at the first thing and the last thing we have here, we have kept the same power and I've multiplied the bases. Okay, as an example, 3 to the second power times 5 to the second power equals 15 to the second power. Or 10 squared times 2 squared is 20 squared. Okay, another rule is division of same power. Division of exponential number with the same power. So we keep the same power and we divide the bases. X to the a divided by y to the a equals x over y to the same power a. So x cubed divided by y cubed equals x times x divided by y times y, and this fraction can be written as a product of three fractions like this. So it is x over y to the third power. 10 to the 4 divided by 2 to the 4, we keep the same power 4 and we divide the bases 5 to the 4. 20 to the 6th power divided by 5 to the 6th power, we keep the same power and we divide the bases 4 to the 6th power. So here we have a negative power, but it doesn't matter, the power is the same. So same power, we keep the same power and divide the bases. 100 to the negative 1 divided by 20 to the negative 1 equals 5 to the negative 1. The last rule is when you have an exponential number here and you bring it to another power. When you have an exponential number brought to another power, you can multiply the powers. So x squared to the third power equals x squared, because this, whatever inside the parenthesis, is brought to the third power. So it means it is multiplied by itself 3 times. So x squared times x squared times x squared. So we have the same bases and we need to add the powers. So 3 times 2 is 6. So that's why we can multiply these powers by each other. x4 to the second power means, okay, whatever inside parenthesis is brought to the second power. So it means whatever inside the parenthesis is multiplied by itself. So x4 times x4, same base, added the powers. 4 plus 4 is written as 4 times 2, so it will be x to the 8. It is worthy to note that x to the 2 to the 3 without parentheses, the priority is to the power here. So x, it is x to the 8. But x to the 2 with parentheses brought to the third power will be x to the 6. Here we multiply the powers, but without the parentheses, it's a different story. Okay, it's enough for here.